we have discussed about addressing modes. And I told you what is an addressing mode. Right? Addressing modes are nothing but the way you take the data from the memory. Okay? So what will generate your address? So I'll just refresh what has been done during your last class. We have seen how many addressing modes? Register addressing mode. This is the example for register addressing mode. We have immediate addressing mode. This is the example for immediate addressing mode. Direct addressing mode. Example for direct addressing mode. And then you have register indirect addressing mode. I explained you about this in my last class. This is called base plus index addressing mode. And this is register relative addressing mode. And base relative plus index. Can you see the difference between this? Can you see the difference between this base index and base relative index? See, it's only the way you take the data from the memory. No, this bracket, see, your entire memory, okay, whatever memory you generate, it should come within the square bracket. You cannot fit, something after square bracket. This one. Yeah, see, this is a different way of addressing it. This is same as move ax comma in the bracket. See, this is same as move ax comma inside the bracket bx plus 10. Have you understood this? It is same. That is not allowed. Yes. See, there are certain things are defined for a microprocessor. We have to use that methodology. It's called syntax. In C program, you cannot write your program as you wish, right? Syntax is the syntaxes. Okay. Now see, base relative plus index. Can you see what is done here? Your data is coming from the memory whose address is bx plus si plus 10. The total address is generated from the bx register, content of the bx register, content of si register, plus one value 10. Okay. See, what do all these things tell me? Ultimately, it will tell you how do you generate an address to get the data from the memory. Right? I understood this. How do you get the data? All these addressing modes tells you how do you get the data, how do you perform the operations. Right? I understood. Your data can be in the register, data can be in the memory, data can be an immediate data. All these things are possible. Okay? Now, next, let us go to the very important chapter, which is called as instruction format. This is very important. I want all of you to concentrate on this. Okay? Instruction format. I told you that all the instructions which you have written in the assembly program, ultimately it is converted to the machine instruction. I told you many times that your microprocessor can understand only the machine instructions. Now, so far you have seen an instruction such as move ax comma bx. Okay, you have seen an instruction which is move ax comma bx. Okay, now this is an assembly instruction. Does your microprocessor understands this? No, it has to be converted into the machine instruction. What is the machine instruction? Right, for 8086 you have a format for that. You have a format for that. Okay, you are supposed to follow this format only to represent the machine instructions for 8086 microprocessor. Understand this? Okay, you need not buy this. The table two tables which I have shared with you in WhatsApp. It will be given to you in the examination. Okay, you just have to use that to convert your assembly program, okay, into the machine instruction. And what is the machine instruction is? It's just nothing but combination of ones and zeros. Okay, and in this format, you should compulsory follow this format. Okay, and this format is for 16-bit instruction format. You have 32-bit instruction format and 16-bit instruction format. Okay, right? So now we are going to see 16-bit instruction format. Right? In that format, there are different bits. When I say 16-bit, suppose if I say 16-bit, this is your actually 16-bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, this is called in 16-bit instruction format. All these are nothing but some data. It can be immediate data, this can be immediate data, or this can be an address. Your instruction has an address also, right? It can be that. Okay, I will tell you in step-by-step mode. Try to understand this. See, your 16-bit instruction format, the first 6 bits, can you see here? 1, 2, 3, 4, 5, 6. See, this is for the opcode. Opcode. Okay. Can you tell me what is opcode here in this? Can you tell me in this instruction which is opcode? Which is opcode in this? MOV, add, ADD. Okay. And then subtract, SUB. All those are called as opcode. So this is your opcode. Okay. This move, which is actually an assembly instruction, okay, in machine instruction, it is represented as 100010. For add, you have something else. Okay, for subtract, you have something else. So this opcode, which is move, this opcode is actually represented by 10010. So this bits, the six most significant bits are representing your opcode. Right? Okay. So moment you have an instruction move ax comma bx to be converted into machine instruction, the first 6 is for, try to understand this. First 6 is for opcode. Right? Okay. Let us come to the next. I want all of you to concentrate on this. It's very important. Later, don't say you're not understood. Let's just concentrate here. Those who come late also try to settle fast and understand this. Okay. The first 6 bits are for opcode. Now, next bit is the D bit. Try to understand it. What is this D bit? This D bit is called as direction bit. Okay, direction bit. What exactly it says? If the data is flowing from the register, it is 0. If data is going to the register, it is 1. Okay? You understood this? Okay. Now, how can you use that? Because in this type of instruction, your D can be either 0 or 1, right? Suppose you have an instruction move ax comma bx. Here, data is coming from the register. Data is also going to the register. Yes or no? Yes or no? Come on. So, this type of instruction for register addressing mode, your D can be either 0 or 1. Okay. But try to understand this. Suppose you have an instruction, say move AX, comma, I will write a memory location here, 100H. Can you tell me what is the D bit for this? Come on, what is the D bit for this? Data is going to the register, yes or no? Yes. Right? Data is going to the register. Right? Data is going to the register. Now, suppose I will take another instruction, say move, okay, move memory, comma AX. Can you tell me what is the D bit for this? D bit is 0. For this, D bit is 0, right? Why D bit is 0? Come on, you answer. Your data is coming from the register. So have you understood about D bit now? Right. Now D is done. W. What is W? W is, it is 0 for byte, it is 1 for word. What's the meaning of this? If the data you are using in the instruction is 16-bit, your W is going to be 1, and if it is a 8-bit, your W is going to be 0. I will give an example. Can you tell me for this instruction what is W? Come on. For this instruction, what is W bit? This W bit is going to be 1. Why? 16-bit. Suppose you have an instruction, say move AL, BL. Can you tell me this AL and BL is a 8-bit register, right? Right? It's 8-bit, right? AX is 16-bit. AL is, you all know that AX can be divided into AH and AL, two 8-bit registers. So can you tell me what is the W bit for this? 0. So have you understood how to put D and W bit? Yes or no? Okay. Now let us see these other three things. What is this? Okay. You have other three bits, which tells you mode bit. From where this mode bit will come? Okay, this mode bit and this will come from the addressing modes. This mode bit and this will come from the addressing modes. Okay, so there are different combinations. See, here you have 2 bits, here you have 3 bits. Okay, you have multiple addressing modes, right? You have multiple addressing modes. Okay, so for all these addressing modes, there are different combinations of bits. We'll see that from the table. Before that, let us see what is this register. Okay, let us see what is this register. See, you see here that you are telling that data is going to the register or data is going from the register, right? Right. Okay, you know. But which register is that? Which register is that? That will come from this table. See here. Can you see here? Which register is that? Right? So you have many registers, and the 3 bits combination tells you about a register. Okay. Now see, 000 for AX register or AL register, 011 for BX register or BL register. Like this, you can select that from this table. Have you understood now? Okay. Now, I was talking about other 2 bits, mode and R by M, register or memory. Register or memory. This is mode bit, this is register or memory. These 2 bits and these 3 bits can be selected from this table. Can be selected from this table, depending on the instruction you have. Okay, depending on the instruction you have. Have you understood this? Right? Depending on the instruction you have. See, these are various tables. Now, to understand how to use this table, let us take an example. Right? Let us take an example. Okay, so I will take an example now. I have to convert this, that is, I have to use this instruction format. I have to use 16-bit instruction format and convert this AX, BX into machine instruction. Okay, how to do that? Okay, first of all, you need to know about the format. This is the format. Okay, this is the format. This you need not by heart, but maybe by doing 2-3 problems you will understand it clearly. Okay, this is the format. Okay, my instruction is move AX, BX. Okay, this will be blank. Assume this is blank. Okay, so your process starts here. What is the opcode? Opcode is 10010. Right? Have understood this? Okay, you need not remember opcode for all the machine code for all opcodes. It will be given in the manual. Don't worry. Okay. But for move it is 10010. Okay. Next bit is D. Can you tell me what is the D bit for this? You have both the choice, right? You have both the choice because here both the registers, right? So consider first 0. I'm going to consider first 0, right? What I'm considering now? You are considering D is equal to 0 means data is coming from the register, yes or no? Data is coming from the register. Which register? From which register data is coming? BX. Let us see the table. Which is the BX? 011. Right? Let us go back. And what you have to put here? Register 011. Right? Okay. Now we have to see what is mode bit and what is register or memory. See here, can you see you considered data is going from the register, right? D is equal to 0 you consider. And then definitely this register which you get here is the register which is data is moving. Right? See, you selected D is equal to 0 means you selected this BX register and you put register BX. Okay, where the data is going? Data is going to another register, right? That is this register, okay, and mode. And see, these two will come from this table. I'll go back to this table. See here. Here, can you see here? Okay, see R by M. Okay, now can you see this? These are all memory, right? These are all memory. Okay, these are all memory, right? Now see here. See here. You're transferring the data from. See, this is your instruction. Move AX comma BX. Okay. You selected D is equal to 0. You selected D is equal to 0. That means your data is going from the register. Okay. And which register it is going from? That you are going to put it in the REG. Understood this? Okay. And then data is going from BX register to AX register, right? It's going to AX register. That is what your R by M is. Okay. Which is that register here? See here, it is, you have to select this. Okay. Now what is the W value here? Tell me.
1.
What is the W value? You have not put W value. W value is 1 here. Okay. Now see here in this table, data is going to which register? It is going to register. See, these are the places where you have to see because data is going to the register. Okay. What is that? What is that R by M here? Tell me. See here. Just look at this. What is R by M? For W is equal to 1. It is your R by M is 0, 0, 0. Can you tell me what is the mode bit? Mode bit is 1, 1. Mode bit is 1, 1. Right. Now, can you put the same thing in your instruction format? What is the mode bit here? 1, 1. What is this? 0, 0, 0. 0, 0, 0. This is not there anyway because you don't have any the address here. Now, can you tell me what is the complete instruction now? Machine instruction 1, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 0, 0, 0. Make a group of 4, 4 bits. Okay, make a group because you have to put it in the hexadecimal format. Okay, can you tell me what is this? Hexadecimal. 8. What is this? 9. What is this? 12 means what in hexadecimal? C. What is this? This is your machine instruction. This is your machine instruction. Okay? So, see here. We have selected this, right? Now, can you tell me what are the changes going to happen here? This is I'm going to give you as an assignment now. Can you do this? Suppose for the same example, table is there with you in your WhatsApp. For the same example, what is the machine instruction? For the same example, what is the machine instruction? For the same example, if you consider D equal to 1. Can you do this now? Suppose if you consider D is equal to 1. Your instruction is move AX comma BX. Okay, suppose if I consider 1, what's the meaning of that? Direction to the register. Okay, immediately which register is you are supposed to put it here? AX. See the table. See the table. Come on. Which register? 0, 0, 0. Okay, can you tell me what is the mode bit and what is R by M? See the table. You selected direction to the register. You selected this register. Okay, REG you selected this. But for R by M, you have to select this, right? Now can you tell me what is the mode bit for this? Mode bit and R by M. See here. What is R by M and mode bit? Mode bit is 1 1 only, right? Mode bit is 1 1 only because it is going to the register, not to the memory, right? Now can you tell me what is that? BX, right? 0 1 1. Your R by M is 0 1 1 and your mode bit is 1 1. So can you just put it here? So your mode bit is 1 1. This is 0 1 1. Can you just put it 4 bits? What is W bit here? Tell me. Why 0? 1, right? Because 16 bit, na? 16 bit, it is 1. Okay. Now see here. Can you tell me what is the? This is 8 and this one 1011. D, this one 1100. Hexadecimal. Hexadecimal. Is it E? This is E. Okay. This is B. Okay. Just check everything. This is C. Fine. You understood now how to convert? Right? Now can I give one more example? Now itself, do it yourself. Okay? I'll give one more example. Same similar one. Move. Okay? Move AX, comma CX. I'll totally use different registers. Okay? Move CX, comma DX. Sorry, I will just use AL, comma BL. It's going to be the same. Come on, yeah. You know what is the machine code for this? Can I get the machine code? I will give you only 2 minutes. Okay, so 100,010. What is the D bit? What is the D bit? You can consider anyone. Okay, consider it as a 0. What is the W bit here? 0. Okay, what is REG? See which register you consider. 0 means coming from, right? From where it is coming? BL. So what is REG? 0 1 1. Okay. Mode will be definitely 1 1. Okay. And what will be AL? What is R by M? 0 0 0 is R by M. Can you tell me what is the machine instruction? Make a 4 bit group. Tell me the answer fast. 8 8 D 8. Fine. Have you understood this now? Yes. Okay. This is very easy because it's only register to register. Let us see some other instructions. Okay. Because you can do various instructions here. Okay. See this instruction. Can you see this instruction? Here, what is the, under which instruction format or addressing mode this comes? Immediate instruction format, right? Okay. Now, for this instruction, you have a data here, yes or no? You have an immediate data. That immediate data will come in the instruction itself. Try to understand this. Okay. Now, the format for the instruction format for this instruction slightly differ from one you see. Okay. Now, what is the format? See here. See here. What is the format? This is what the format. See. You will have 1011 as a prefix opcode instruction, machine instruction, and then you have W, and this W is 0 for 8-bit data, W is equal to 1 for 16-bit data. Fine. And register. Which register you are going to use? See, one thing you remember here, for an instruction like move H, 4CH, there is only one register, right? And data is always going to the register. There's no question of data is coming from the register. Have you understood this now? Okay. For instruction move, say AH, 4CH, we need not use that earlier instruction format because data is always going to the register. Okay. And you have an immediate data which is going. So what you need to do is you need to put that immediate data in the instruction itself. That's why the format is 1011. Can you tell me what is the W for this? 0, right? Because it is 8-bit. 0. Which register? After the register, there's only one register. What is that? AH register. Can you see the table? See what is the REG for? What is REG for this? AH. Come on, I have already given you the. It is for AH. For AX, AH. It is same. Okay. What is that? Are you sure?
Yes.
Let me check. Yes, 100. Correct. Okay, fine. Can you tell me what is the instruction? Machine instruction? Just make a group of 4 bits. That's all. Just make a group of 4 bits, convert it into B4. See, this is B, this is 4. What is next? What comes next? The data. Right? Data. Okay. This 4C has to come in the instruction itself. Right? Okay. Then 4C comes here. Have you understood this? Now, can you convert? I will give you one more example. I'll give you one more example. Now, this is very interesting. See here. Move AX, 1, 2, 3, 4, H. Move AX, 1, 2, 3, 4, H. Can you convert this into machine instruction?
The 1011 is for move.
Yes, it is always constant for this. Always constant. Okay. 1011. Next, what is W? What is W for this? W is 1, right? Because it is 16-bit. Okay. Can you tell me what is REG? REG is 0, 0, 0. Right? Okay. Can you tell me what is the machine instruction? 1011. 1011 is how much? Is it B? Check it properly, my dear. 8 plus 2, 11. B, right? B, yes, B. Okay. It is B and this is 8, right? Okay. So your machine instruction will be B8. Is it over? No. Okay, now tell me here, when you put 1, 2, 3, 4, okay, lower byte will come first. Okay, lower byte will come first and then higher byte will come. Always remember, when you put 1, 2, 3, 4 in the instruction, machine instruction, lower byte will come first. Which is the lower byte here? 3, 4. So first 3, 4 comes, after that 1, 2 comes. So this is your machine instruction. This is the machine instruction for this. Fine, let us do more examples. Okay, I will go forward. Let us do more. Can you do this? Come on, come on, come on. Fast, fast, fast. Very fast. If you are fast in this, best. Come on, come on. I want everyone to do this. You need not do any practice after this class. Right? Okay, come on. What comes first? 1, 0. Come on. Then what is W? 1. Come on. It's done. It is 4C. Sorry, it is, which is the register? 0, 0, 1. Okay. Now, can you tell me, this is B9, right? So, B9, 4C, A, D. Fine? B9, 4C, A, D. Fine. Do you know what is Little Indian and Big Indian? I told you, I think in digital design, people, teachers must have told you, what is Little Indian representation, Big Indian representation? You don't know? I told you in my class, right? Little Indian and Big Indian. It's not Indian, it's Indian. Right. See, when you write this, for example, some binary, okay? Understood this. We consider this as a low significant bit, this is most significant bit, right? And accordingly we write. It need not be true for all the cases. Sometimes this can be, in some cases, in some standards, this can be more significant, this can be least significant. Right? So we are using little endian, and then in some microprocessor they may use big endian. So this is what we use the little endian form. Okay? So in little endian format, your lower byte will come first and upper byte will come the next. Okay? Now next, let us see one more example. See this. This is very important. Now, what is this instruction? What is the addressing mode of this instruction? Direct addressing mode. Why it is called direct addressing? Because your memory is mentioned here, yes or no? Memory address is mentioned in the instruction itself. It's an example of direct addressing mode. Your instruction itself is having the memory address. Okay. Now, how do we convert this into machine instruction format? For this, we have to use our earlier, the first format which you have used. Right? Okay. Let us do it accordingly. Tell me, from where you have to start? First 6 bits, right? What is the first 6 bits? Opcode will be 1, 0, 0, 0, 1, 0. Right? So what is this? This is going to be your opcode. This is opcode. Okay. This is opcode. Done. This is done. Okay. Now, what is D bit? What is D bit here? You don't have other option, right? Data is going to the register. Data is coming from memory now. Right? Okay. Now, D bit is going to be? It is going to the register. See the table. What is the D value for data is going to the register?
1.
It is 1. Your D bit is going to be 1. Can you tell me what is W?
1.
W is 1. See, always, moment you put D bit, you put D bit, you know that data is going to the register, right? Can you just immediately put your REG? Immediately put your REG. You said data is going to the register, D bit is 1, immediately you put the REG. Can you tell me what is REG? Look at the table. 0, 0, 0. Right? What is left now? What is left is R by M and, sorry, here you have mode bit. You have mode bit here. You have mode bit here. You have mode bit here. And here you have R by M. Okay, now for this we have to refer to the table. Right? I will go back to the table. I will tell you how to refer to the table. I'll go back to the table. See here. Now, your address, you see this table. I will tell you how to use this. See, your instruction is move AX 1, 2, 3, 4, right? Some address. It is 16-bit address, yes or no? It is 16-bit address, right? What is there inside is 16-bit address. Now, if you see this, okay, can you see here one 16-bit address? Right, you don't have anywhere a square bracket. Actually, it is a square bracket and a 16-bit address. Okay, see here, and you know where you have, here only you have D16. And this D16 means 16-bit address inside the bracket. Right, so you have to use which mode for this now? Which mode bit? Your mode bit is 0, 0. Have you understood now? Right, your mode bit is 0, 0. Suppose instead of having move, instead of having this, if I have move AX comma SI, for this also what is the mode bit? 0, 0. See, here it is. Right? Your data is coming from the memory. Which memory? It is within square bracket? Yes, sir. Right. Now, for this, your mode bit is 0, 0. What is R by M? R by M is 1, 1, 0. Now, for this, your mode bit is 0, 0. What is R by M? 1, 0, 0. This is the way you want to select. Right? Now, for our example, can you tell me what is the mode bit? 0, 0. What is R by M? 1, 1, 0. So let us go to our question. Let us go to our question. Here, right? Okay. Now, can you tell me what is mode bit?
0, 0.
What is R by M?
1,
1, 0. Now, you have got your 16-bit now complete machine instruction. Okay. So now, can you tell me what is that? Now, this is followed by, see, this is your 16-bit instruction and this is followed by the address. Address is there, na? Address is there in the instruction itself. So, you have to write the address here. What comes first? Lower byte comes first. 3, 4 comes first. 1, 2 comes next. Okay, can you tell me the complete hexadecimal instruction?
3, 4, 2, 1.
This is what coming from this. So next class we will do many problems. Varieties of problems we will do. Okay? When we do varieties of problems, okay, then definitely you will understand it clearly. You will not do any practice for this. Enough. Right? I will share 1 or 2 videos in the WhatsApp. Just see that. Okay? Where different examples are done. So only way to practice this is use different instructions and do it. Different types of instructions and do it. Fine? I've understood this. Okay. So now this is for this. Now I will give you one example. Now I will give you one more instruction. Can you do it? Can you do this? I told you. Do this. Move x comma si.